When we first looked at exponential equations, we looked at powers of 2, and we saw that when the exponent increased by 1, our answer increased by a multiple of 2. So when our exponent changed from 1 to 2, our answer went from 2 to 4. 2 times 2 gave us 4, 4 times 2 gave us 8, and so on. Then we represented our exponent with an x and our answer with a y, which gave us our exponential equation. We plotted our x and y values on the graph, and then we asked, what about this region? What happens when x is 0 or a negative number? That's when we introduced the idea of extending the definition, and instead of seeing what happens when our exponent increases by 1, we thought about what happens when the exponent decreases by 1. So when our exponent goes from 3 to 2, we end up dividing by 2. And when the exponent goes from 2 to 1, we divide by 2 again. And continuing that pattern allowed us to extend the definition. Now we're going to continue in the negative direction and see if we can find a pattern with the negative exponents. If we consider 2 to the negative 2 power, and if we follow our pattern, dividing by 2 each time, we would get 1/2 divided by 2. Dividing by 2 is the same as multiplying by 1/2, so we could write this as 1/2 times 1/2. So instead of dividing by 2 each time, we could think about it as multiplying by 1/2. So 2 to the negative third would be our previous answer times 1/2. So this is our previous answer. And we multiply that by 1/2. So 2 to the negative 3 means we're multiplying 1/2 3 times. And continuing the pattern with 2 to the negative 4th, we get our previous answer times 1/2. So it looks like we're finding a pattern here. If our exponent is negative 4, that means we're multiplying 1/2 4 times. If our exponent is negative 3, then we're multiplying 1/2 3 times, and so on. And when we multiply fractions, we multiply the pieces on the top and the pieces on bottom. So in this case, we would get 1 over 16. But there's a different way we could write this. We could write this as 1 over 2 to the 4th power. Similarly, we could write this line as 1 over 2 to the 3rd power. And continuing on, we would have 1 over 2 to the 2nd power. And 1/2 we could think about as 1 over 2 to the 1st power. Even the next line fits the pattern. We could think of this as 1 over 2 to the 0th power. 2 to the 0 is 1, so this fraction would just equal 1. But the main thing to notice is that we found a shortcut to write negative exponents using positive exponents. If we have some number to the negative m power, we could write this as 1 over that number to the positive m power. So 2 to the negative 4th power became 1 over 2 to the 4th power. To find this pattern, we looked at powers of 2, meaning 2 was our base. If we considered powers of 3 or 4, we would see the same thing. And in particular, we would see that any number that we raise to the 0th power is always going to give us 1. I encourage you to list out powers of 3 and 4 and see why that's the case. But that gives us another shortcut. Any number to the 0th power equals 1. Let's do some practice with these two shortcuts. Let's rewrite 3 to the negative 4th power using positive exponents. And using our shortcut, we know this is equal to 1 over 3 to the positive 4. Let's try another. What if I gave you 5 to the negative 2 power How would we write that using positive exponents? We would have 1 over 5 to the positive 2 power. Now, what if I give you 7 to the 0th power? What would that be? Well, we learned that any number to the 0th power equals 1. Now let's say we have 8 to the negative 1 power times 6. We have some operations here, so let's consider our order of operations. We have an exponent, and we have multiplication. So our order of operations says simplify the exponent and then multiply. So 8 to the negative 1 power, we can write as 1 over 8 to the positive 1 power. 8 to the first power is just 8, so this becomes 1 over 8. Now we have a fraction times a whole number, so we need to turn our whole number into a fraction. So 6 becomes 6 over 1. Multiplying across gives us 6 over 8. And we can simplify this further. 6 is 2 times 3, and 4 is 2 times 4. So we can cancel out a 2. So our final answer is 3/4. Let's try one more using variables. Let's have 5x squared times y to the negative third times x to the third. Okay, this is a little bit more complicated. Let's use our PEMDAS to guide us through it. We have exponents and multiplication. So first, we need to simplify this piece, and then we can multiply. So we'll keep our 5x squared the same, and y to the negative third we can write as 1 over y to the third. And then we'll keep our x to the third the same. Now we have 3 pieces that we're multiplying, and we can multiply numbers in any order. So let's group the x's together. So we'd have 5x squared times x to the third times 1 over y to the third. Now we have x squared times x to the third. We have multiplication with the same base. So using a shortcut from the previous video, we can write this as x to the 2 plus 3. Or you could think about it as multiplying x 2 times and then 3 more times. So we're multiplying x a total of 5 times. And now we have a whole number times a fraction, so we'll need to rewrite the first part. We'll have 5x to the 5th divided by 1 times 1 over y to the third. Multiplying across, our final answer is 5x to the 5th over y to the third.